All right, so I'm in chapter 3 here in AP Stat. I'm looking kind of like an overview of everything, part 1 of our notes here, and will encompass a lot of chapters 1 through 6, bits and pieces here and there in it as well. But mainly I'm going to talk about graphical displays, and we will be discussing these items within the unit. Let's take a look at some bar charts. Let's take a look at some dot plots. Let's take a look at some histograms. Some stem plots, and all that fun stuff. We can even look at the center and the spread with data, clusters versus some gaps in data, some outliers. We'll look at some modes and some different shapes, cumulative relative frequency plots as well. We'll look at all this stuff in here, some skewness of graphs. So that's just a little overview of everything that you're probably going to get in these next couple videos. So let's start from the beginning with everything, okay? Data. All right, data. It's basically just observations, all right? Data is observations, data is numbers, but it doesn't have to just be numbers that you're getting. Data could be the observation that has been collected as well, okay? So the observations that have been collected could also be data. So in statistics, it says here that we collect the data, analyze the data, and we interpret the data. All right, that's what you're doing. So somehow, in some manner or fashion, whether it be with some kind of graph or chart, we collect the data, and then you look at your data, analyze it, and then we interpret it. And basically, that's what you're going to be doing all throughout AP Stat. We're going to go over first, how in the world do we collect all this data? Then how do we analyze what we got? And then how do we interpret it, which is the very end of the course, which is where stuff kind of gets a little bit more heavy. And we're going to make those decisions based on those interpretations, which again is at the end of the course when we're looking at some confidence intervals of things and some hypothesis tests along the way. Statistics means basically you're collecting data, analyzing data, and then summarizing the data. That's what all of statistics is, okay? But the framework behind statistics is to interpret it. All right. Most importantly, we want to draw conclusions from the data. Okay. This is like for some of you day one. Down the line, we're going to get into some more heavy duty stuff, but we got to first get you there. So our job is to go through a lot of this and tiptoe you through so you can understand how it all connects. And the big point is data is useless unless you know what to do with it. Who cares if I can collect the data of how many Pop-Tarts are made? It doesn't matter. I can say, well, this building, Kellogg's makes this many Pop-Tarts, but if I have no idea what to do with the data anyway, so great, I know how many Pop-Tarts they make. The idea here is to use it somehow. So, getting to that, a population. All right, a population is a complete set of everything studied. Okay, this is a key idea that we're going to go over. All right, population versus sample is eventually what we're going to be hitting on here. So for example, the population of this classroom is everyone in it right now. So in a classroom that you're in, everybody, that's the population. The population of EHS is everyone in the school, right? Our entire school is the population of it, okay? The population is the complete set of all elements being studied, everything being studied, okay? Everything. Is it always appropriate to look at the entire population? All right, so here's an example to kind of answer this question hopefully for you. So for example, you have a presidential election and they tell us data from the polls, right? Who looks like they're winning? Who looks like they're losing, right? You're looking at the poll. Have you ever been asked to be in a poll before is the question I have for you, right? Have you? All right. Who gets asked in these polls? All right, they don't physically go to everyone and ask everyone in the United States to answer this. And if they refuse to answer it, then they don't give out the poll, right? They literally have to take a sample, okay, of the entire population. That's what they have to do. So if a population is everyone, then a sample is a subset inside the population, right? So in order to answer how everyone feels about the President of the United States, we can't ask every living being in the United States. They have to take a sample of people inside the population. So I hope that idea makes sense, right? Logically, does it really make sense? Can't take it all. So a sample is a small group of the population. In statistics, we will generally deal with samples or small groups to collect the data. Naturally, it makes more sense. Now, if a population is that small, feel free to use it. If it's small enough that you could just use that to get a better gist of what's going on. However, if you wanted to poll the entire EHS about something, it'd be a little more difficult. But polling this class would not be as difficult. One class of 30 kids, we can do that. All right? Again, can't poll everyone, that's why. So are there times where you may need the information from the entire population? Yes, there may be times where you need the entire population. Have you ever heard of a census before? Okay? A census is something that comes in the mail and then sometimes gets sent home wanting to know all information about your household. Okay? Oftentimes it comes in the mail and the owners of the homes are asked to fill out the information of those homes and what's happening inside of them. And a census is the entire population, basically. Okay? So a sample is collected. It's collecting data from a group in your population, right? Sample is a group in your population. A census, for example, is collecting data from the entire population. That's everything. Okay? A census would be the example of being a population. So, let's think about a presidential election again. And if we were trying to find a sample, how would I find it? How would I find that sample? And that's the crux of what we're talking about here. Do I just ask all of my besties, hey, guys, who are you voting for? And then is that a good representation of all of the country? Well, all my best friends, they're voting for this person. So does that mean everyone is? No, not at all. Okay? That's going to possibly, which is what we're getting to, show bias. All right? Would we get a good cross-section or sample of how America will vote by only asking our friends? The answer is no, not at all. Right? And here's what I want you to think about. Our friends probably have the same likes and dislikes as you. That's why you call them your friends, right? Lots of similarities between you and them. So more than likely, you're probably, for the most part, going to vote similar to the people around you. Not all the time, but mostly. All right? So to get a good sample, we should probably spread out the different types of people, right? You got to spread out the people that we poll. So maybe we should make it a little bit more random about who we come in contact with. If you went to a Republican convention and asked them if Trump would win the next presidential election, they would probably almost all say yes. They're biased. They're Republicans. He's Republican. They would say, sure, he's going to win. Yeah, obviously. It's probably where they're going with it. If we released a poll saying with 90% certainty that Trump would win the election again, most people may go out to the polls and vote for him. They're like, well, it says that 90% of the people are probably going to vote for him anyway. Okay? Now, why? Why would we do that? Because people want to vote for a winner, honestly. It's the truth. When you have a team that keeps losing over and over and over again, why do you want to continue to go out and support them? All right, example, the Cleveland Browns. Why are you going to go out and support them after a while? It just kind of gets old. So this is the reverse of that. This is saying if we can get a poll that comes out saying that 90% of the people are voting for Trump for the next election, then what's going to happen? Either A, everyone's going to go out anyway because they already know that it's going to win. B, people will just be deterred from going out to vote because they'll say it's not going to matter anyway, so they won't. So no one who could vote against him would. So that's another option. And C, people will literally just switch their votes because they want to vote for somebody who's winning. So if we sent this out, we biased the decision. You bias people's decision to vote a certain way if you do that. So if we collect or take a sample, it must be collected randomly. This is key. All right? So from this video, things to take away. Sample is a grouping from the population, and we must collect things randomly. Okay? Randomly. That will make your poll, for example, fair. All right? So we have types of data. A parameter. Okay, so here's some verbiage, some terminology. You should basically be taking notes on everything, but some vocab here. Parameter is a characteristic of the population. Something we cannot measure directly is a parameter. A statistic is a characteristic of a sample. All right, it's a characteristic of a sample. So we got P goes with P is what I got here. So parameter, right? Population. Parameter is the population, right? S goes with S. What I mean is statistic, sample. All right. So are you digging what I'm saying here? Parameter goes with population. Statistic is a sample. If we found the hair color of everyone in America, that would be a parameter. Hair color of everyone in America, parameter, because it's everyone in the population. Everyone in America means we are dealing with a population, so that is a parameter. Okay? So it's two things that mean the same thing, but one is for a large overall group of everything, and the other is for a small one. So maybe everyone is blonde. That's a parameter. Next, if I asked you to calculate the hair color of people in this room, you would probably make a list and count it, right? So, for example, let's say we had 7 blonde-haired people, 15 brown-haired people, 12 black-haired people, right? This is a simple frequency table right here. A simple frequency table that we just developed. All right, the blonde, brown, and black-haired people are called your classes or your groups, okay? Classes or groups. The 7, 15, and 12, they are called your counts or frequencies. So groups, frequencies, or counts, right? Classes or frequencies and counts, okay? A frequency is how often something occurs, all right? We have frequency distribution. Frequency distribution is a list of values or classes with corresponding frequencies or counts. So a frequency distribution table could look something like what I just showed you. All right, the class width. This is the difference between the lower and upper class limits. All right, the class width, all right, is the difference between the lower and the upper class limits. So what's a lower class limit? Lower class limit, it's where the class or groups start its smallest value belonging to a class or group. All right, if this is getting too heavy because it's going too fast, this is a video. Pause it, okay? Pause it and write the stuff down. Lower class limit, it's where the class or group start its smallest value belonging to a class or group. We'll eventually get to an example that we can all look at. The upper class limit, it's where the class or group ends its largest value belongs to a class or group. So it's where the class or groups end its largest value belonging to a class or group. All right, so I'm going to stop the video right there. All right, we're talking about lower and upper class limits. When we come back, we're going to start making our own frequency distribution kind of tables here. Steps for making them, okay? Remember, if you have any questions or concerns, please do not hesitate to ask. And remember, if this is moving too fast, you pause the video, you rewind, you go back. Okay?